A warm welcome to all of you for this basic concept VAV, value analysis and value engineering. So in this next 45 minutes, I'm going to cover these are the contents, some historical perspectives of VAV and introduction, and next I'll just quickly walk through about the cost, price, and value. There is, I hope you all know it. Just because this is a VAV, just I want to make sure you all understand the basic difference between cost, value, and price. And then I'll walk you through the what is VAV, what is the difference between VAV, like when we apply VA, when we VE, and then I just want to give you a brief introduction about the should costing, because we are dealing with value and price here, so we really want to know how we do the costing as well. And then I just like to tell you what engineer roles and responsibility in the industries, and a few costing tools which is commonly available in industries, how they use it. And at the end I'll just go walk you through the project steps and project steps, a dummy project, and steps how we follow it in the industry. Without next, I'll just quickly, next slide, I'll move now. So this is just a few historical perspective and introduction to VAV. Like VAV is generally a new thing which is in industry. If we compare all the manufacturing side, it started in during World War II, and it is started by Mr. Lawrence de Mille, who is an engineer by training. He is known as father of VAV concept. He wrote a book in 1960s around. In his book Techniques of Value Analysis and Engineering, defined for value analysis. In this book, he writes like many creative approaches which has its purpose, the efficient identification of unnecessary cost. Like when we do any manufacturing steps or we build any product, from start from the end, we will have a lot of unnecessary steps. In this book, he has written all the techniques how to reduce those unnecessary steps which are not giving any value to in the product or in a service. So in this book, he has written that. Next is a value analysis definition, like it is identify the function of product or services or provide those functions at a lowest possible cost. So it is like we are looking for the functions which we can get at lowest possible cost. That's a value analysis definition. Other definition is it's a cross-functional team approach. Definitely, we cannot do it we cannot say it is a engineering department work. It's a sourcing department work. So it is cross-functional team approach. Like when a VAV is doing for a product or a service, so all the departments do it together, and we need all department support to do a VAV project a successful one. So with this, I'll go to next slide. Yeah. So in this slide, I'm going to cover basic definitions of cost, price, and value. We all know what is cost actually. It's like there's a marginal difference between cost and price. When we manufacture a part or product in manufacturing sector, like when we cost incurred from manufacturing, that is cost. And when it is go to retail, like when we as a customer or consumer buy it from the retail shop or any shop, we, as you may be seeing, MRP. So it's having all the profits. Like in cost, we add some GST, all the taxes, then it's become price. And value is it's a usefulness of any product to a customer. It can never be defined by money, or it varies from customer to customer. I'll just take an automotive example. Like in automotive, we have in market lot of cars. Like Nano is available. We have, if you take Tata, in Tata we have some luxury brand, and we have Mercedes. If and the Nano, it's for particular set of middle class, I can say, or lower middle class. And we have Tata other vehicles, like which is middle class domain, and luxury vehicles like Mercedes, other brand. I mean. Luxury cars which is targeting a high luxury customers, so it varies from customer to customer value. In this slide, I'm just going to touch value engineering, basic definition of value engineering and value analysis, and what is the difference between value engineering and value analysis. So VE, like it is applied for a new product actually, and it's applied during the product development. The focus here is reducing cost, improving function, or both. by way of by doing teamwork, and it takes this takes place before any capital cost, tooling investment, or plant or any equipment we purchase. So value engineering happens before we have invested in any factory or any tooling cost. So it's a prototype. Basically, when we are going it for a new product development, then value engineering comes into picture. Value analysis, we do it for existing part, and the aim here is to reduce cost, improve product function, or both. These include cost, function, alternative component, and design aspects such as ease of manufacturing and assembly. Both the purpose is same, like value analysis and value engineering. We are trying to reduce the cost without affecting any function, without affecting the value. Maybe sometimes we try to increase the value by reducing the cost to satisfy our customers. But purpose for both the value analysis and value engineering is same. We are targeting to reduce the cost. Here, just a few differences. In the right hand side, I have written like VA for existing part, VE for new product and services. VA, we concentrate on manufacture and after sales. In VE, value engineering, we say prototype, design, and pre-manufacture. And in value analysis, we are like process innovation. In value engineering, we say functional breakthrough. And purpose of like value in analysis, we say unnecessary cost. And here in because it's a new product development in value engineering, so we try to increase value. Yeah, so with this I just wanted to touch on the should cost. Hope many of you aware of the should cost, or I don't know, not, but this is a term used in industry for doing estimation. Like if I'm doing estimation of my part or a product, then we call it should cost. And the definition like should cost is an analysis conducted by customer of the supplier expenses involved in delivering a product or service or fulfilling a contract. The purpose of should cost analysis is accessing an appropriate figure to guide negotiation or to compare the figure provided by a supplier. Basic like terminology to understand participant here, like should costing. If I am a customer and I am buying a thing from a supplier, like if I buy one part from a supplier and a supplier charges me a X price, I don't know whether it's X price is correct or not. So to know that whether he's charging me a right price, I'll do the should cost. And should cost is done by my team, or I'll do it myself if I'm expert in that. Below in the left hand side, some benefits of should cost analysis, like it can help negotiation for existing part. Analysis can be like we can help with this analysis with proper transparency. We can help convince our stakeholders and can help in execution strategic sourcing steps, and can predict forecasting, like can predict help in saving forecast. Definitely when we do anything, we will have pros and cons. So in the right hand side, I'm just listing some pros and cons, like it is you the true cost of a product, help you to choose the product with best overall price. These are the advantages, and disadvantages can be difficult to calculate if we are missing a data. Like when we do costing in we need a lot of data. In couple in next slides I'm going to just touch base on that. And it's not appropriate for all the businesses. Not appropriate all the businesses means like if sometimes we have a monopoly supplier, and if we are doing it for a cost and we our should cost analysis say no, supplier charging a like X price and we come with very less Y price. But we know supplier knows he's the only supplier in the market, and definitely he will say whatever your price, it's I will charge X. So we need to really know which business we are doing it. So in this slide, as just should cost, I've touched left hand side. We have like final cost. To get final cost, what are the things we need? Definitely one is the material cost. In material cost, when we say material requirement we need, and the material cost. In material cost, two things comes. One is net and gross weight. And then after material, when we buy material, then we need to process it, because we buy raw material and then all the manufacturing process starts. On manufacturing process, we need following, like it's involved direct labor, it involves machines. We have direct labor. Again, when we go to labor, we will have like under that we will have skilled labor or experts. And then machines, when we go, it will it again we need amortization, interest, energy, maintenance cost. Material included, tool material here means including tool, and those things. And then another aspect comes in the process cost is indirect industrial cost. In indirect industrial cost comes like indirect worker, machine and tools, plant energy requirement, setting, change of process requirement, maintenance, plant maintenance cost, and material movement and storage, that's inventory. These process costs include all those things. And after that, we need like selling. SG&A is nothing but selling, general, and administration. That's nothing but in short terms, like overheads we call it. It in the overhead, it comes all supplier cost incurred outside the production process. Like if we are doing some administration, or if we are doing marketing, or we are doing advertising, that comes in this bucket. Then comes rejection. Rejection, maybe most of you say why I have to pay for rejection, but definitely in manufacturing process, uh, rejections do happens, and we as a cost engineer, we need to like take care of those rejections as well. And the finally we add the profit. This is manufacturing profit markup. That's like financial expense of a material for the material acquired or profits. So these are the things comes in when we do a costing for a part or a product. Quickly, I'll go to the next slide. This slide, I just want to touch like maturity model. When we do any costing, like starting, we do as per like expertise, and expertise varies from person to person. So, and but industries, we have some tools which provide us the all the market data we will have. So based on that, at least we can start with the basic industry cost model based on our experience, based on our current database. And best starting point will be modeling and discussion, just to start a discussion with the supplier. When our basic model is finished, we do like when we go to supplier, definitely there will be supplier price is X and our should cost say Y. There is a difference of 20%. Supplier say all the blah blah blah. He will say no, my God, your data is wrong. So in that time, next model comes into picture. We say you provide us the data. We will fine tune our cost model. So then the gap initially was 20%. Then it comes to 10%. That's the one way of negotiation. The next model is supplier specific model. Like it's in this here, we just do as per the supplier manufacturing facility. We if supplier is close to us, he provide all his data and we do costing. And as per supplier, this is called supplier specific model. For one supplier or two suppliers per our requirement we do. And then the supplier benchmarking. Like here what we do, we build a lot of supplier cost models and do benchmark which one is like who is to at optimization. That is called comparing supplier cost. And come to this is a more or strategic procurement discussion point here, actually supplier benchmarking. So these are the four model when we do costing for any commodity or any product. With this, I'll move to the next slide. Yeah, capabilities, should cost capabilities. Again, it's preferred to like we do it where we can use it. Like one is procurement, which definitely use it for supplier negotiation. Utilize cost model for negotiation with supplier. That's a one lever I can say. Other one is manufacturing and assembly, to analyze the process cost, cycle time, and the production cost here. And the third one is concept costing, determine cost effective design here. Just I'll touch like if engineering team have some concept, like if part they are having few concept with them and they are stuck in making a decision which concept they should go. Here cost engineer can help with their cost analysis, provide them which is at what cost. He can give the for all the concept. If the engineering team has three concept, he can provide the costing for those, and helping in taking decisions for engineer to go with which concept. Again, benchmarking with the competitive product. This I'm going to benchmarking I'm going to cover in my dummy project, which I have chosen in the next slide. So engineer roles and responsibility. This what I wanted to tell, like what is the in like VAV engineer responsibility here. Like here I have chosen car view, a steering view I can say. Here like where steering like all the departments sits, like here like sales, R&D, procurement is at the steering seat. However, a VAV engineer, he's navigating. Like if a product, he can tell which process you go, which supplier you go at cheapest level you can guide. So we, as a cost engineer or VAV engineer, will guide you by why I'm showing this Google map, because if we have to go to any one place, we will find many routes. And but Google will tell us which is the best route. So same way, cost engineer can tell us which is the best concept or a best way to, concept or best cost I can say. Reducing the best cost, you can go with which concept. The cost engineer can help with the cost transparency here, take decisions for engineering team or R&D or procurement teams. Yeah, here is like where VAV can support. Already I have covered most of the topic. Like here, like I am writing material substitution. If a R&D team do some material changes and they wanted to know the cost, getting a quote from supplier is challenging. If we have a VAV team or a costing team inside with us, they can support us. What is the change of material cost? What is the change of cost when we do any material substitution? And then with this we can with our cost transparency we can provide cost optimization, and we can suggest alternate manufacturing process, and all is for competitive cost, to be competitive in the market. Okay, cost avoidance means if supplier is asking for a price increase, where here like should cost engineer can with his cost transparency he can challenge with the procurement guy. He can challenge, no, whatever cost we are currently paying, it's a right one. So that way cost avoidance we can support. Design to cost is nothing but, again I've already told, like if we have a money concept, we want to know which concept is which cost, it's again engineering. We want to know the cost of all the three concept, which is the less cost, which is at less cost, and we can help in taking a decision in engineering. Hope all cover here. Yeah, it's covered now. Yeah, this slide I just want to touch how we can support, like it's VAV engineers cross functional. We can support in engineering, we can support in production, we can support in after sales, purchase, and marketing. Like if we take up in my next project I'm going to take, which it's a cross functional project, I'm going to explain in with all the departments here. So in this slide, these are some of the software which in industry we use. DFM is like designed for manufacturing, and a priori again it's a costing software. Costometer, solid work costing, micro estimating for manufacturing, team center product cost team center product costing. Like I'll not say all every industry uses all this, but every industry either like main MNCs uses either one of the software based on their requirements. Like if you take HCL Technologies, they uses DFM and a priori. If you go to any like other US MNCs, definitely they will use a priori, and if you take any European MNCs, they will use team center product costing. Now, yeah, in this, I'm just taking steps for project. I'm just coming to my dummy project, which is the next slide. Before that, what are the things in the projects required? We should have a current situation, and definitely it should be situation should be defined, like if we have a product and which product we are losing the market, and we should have a target situation as well. And by doing like we if we both have, we know the current and target situation, and in between we should like one estimate for a budget and return of investment, like how much cost, how much like money I have to spend to arrive at target situation. So this we should have it in an initial stage itself. For the this I'm putting in a purpose, like we should have a purpose defined clearly. We should know how to do it, like we should have a timeline. We cannot take like years together. We should have a proper timeline for that, and we should have a team, like who will do it, cross functional team. Previous all the like department I mentioned, we should have a cross functional team. We need whom, like we should identify persons there who can participate in this project, VAV project. And then we should define accountability, like all the finding team is not important, like which is what a engineering guy has to do, what so we need support from procurement team, and those we should define their responsibility. And in this results, like what are the results we usually get from which we have some ideas generated, and we will next with we should estimate the impact of those idea, estimation impact, then implementation. Like some design changes in the product, definitely we need to go back to engineering will do some testing. So getting in those changes in the those changes in the product, it will take time. So implementation is also take time. But as a VAV engineer, like as a our roles and responsibility ends at implementation. This I just move to the next slide. I am defining I've just taken a benchmarking project, and I'm writing what are the steps in a benchmarking project. Like first we need to have a product, and in that we should have a defined clear purpose of the project and collaboration team, which I have mentioned. and which product we are facing. There I am writing with competition with the market. And then tier down I'll explain like it's a disassembly of product, identification of parts, gather all technical information needed in the tear down stage. And then is the cost analysis, estimation at part level, sub-assembly level, cost transparency. After doing that, it's a comparison step. It's like one-on-one comparison at functional level, and then material process like yeah, I'll explain in the next slides. But the next step is idea generation. In this benchmarking without compromising in functionality like value, which we call, and the less cost higher implementation. In implementation definitely we it's in going in the next stage, which is for other departments, like effort, time, accountability comes here. Yeah, with this I think I can start. Yeah, this is just a dummy project. Like, if you hope you may have come across with a situation where you want to go for buy AC. You see all the I've taking AC example, air conditioning example. It's three, like we have. If you see specification, capacity same, rating same, but cost is different. Here, our sales team faces a lot of competition. Like, when if our sales guy working in TSL, and if all the like capacity ratings is same, definitely people will buy TSL product. But on the other hand, if last one I think it's Daikin we are at 40K, the dummy one number it is, and dummy sales guy was having a stiff competition. He say TSL guy products are sold lot, and I need to analyze why it is at 30K. So there a purpose we want to know target situation to understand why same specification, why it is at 30K. So we have chosen three products here. We will do tear down for all the products and analyze one on one. Like, we will generate a bomb. We will analyze what, again I'll go to my previous slide, what material in TSL using, what material is Hyundai using, what material is Daikin is using. The bomb we will analyze, and we will try to analyze the difference, why it is at a bottom level. We will do all the part costing for all the three products, and then to the next step, which is this is just like how a cost analysis looks like. Like, I've taken product 1, product 2, product 3 here, like processes it's listed here. Like, definitely we will have material, molding, casting, forging, bending. Then if we have like all flattening processes, annealing, weld preparation, tack welding. As a cost engineer, we have to analyze all the manufacturing cost, and then finally comes at one number. These numbers are just dummy. Don't compare it with the previous number. This is just a dummy example. And then we find out, if suppose product 1 is using stainless steel material, which we know it's costly, and product 2 is using steel material with coating. Those kind of things we can analyze and give our ideas to engineering team why we are using a costly material. If product 1 is using manufacturing this way, why can't we do it this way? So our aim is to finalize those gaps and pass it on to engineering team for them, so that they can change it. But we have to be careful here. Like, I think I'm already in the next steps. Yeah, I'm idea generation. We have to be careful while like giving those ideas. We have to like see if there is any compliance issues, like if there is any patents are already filed. Those things we have to see. If supplier is using some special material which is not available in the market. So before implementing in our product, we need to see all those factors, and then try to implement it in our product, and try to reduce the cost of our product as well. Yeah, I think I'm already at last. Thank you.